I hope this explains it. Yeah, it's a good question. So it's more where you start off, like that question is quite tricky if you haven't looked at identities in a while. And it's just looking at the idea that if I told you 3x is equal to something x, and it's like, oh, find the value of a. Well, because this means is the same as, well then they're matching off, and that means that the coefficient of the x has to be 3. I mean, there's nothing else going on here. So a has to be the 3. And it's just called identities. It's in book 1. Let me just even have a look at a few more. Like if I said to you 3 to the power of something gives me 3 to the power of 4. Well, again, because that means this is the same as this, then what's missing in here, I mean, you could call it x if you want. This missing thing has to be a 4. If I said to you, I have a 3x and a 2x, and that's equal to, I don't know, a b times x. And again, we look at our identities, the coefficient of the x here and here, 3 and 2. So the 3 plus the 2 has to be equal to the b. So b is equal to 5. And that's what I was doing in that question. I was equating the real number with the real number. So if I said to you 4 plus 2i is equal to a plus bi, tell me what a and b are. Well, look at the I. Just like up here, I might have looked at the x. Look at the coefficient or the number that's attached to the I. So in this situation, b is equal to 2. In this situation, a is equal to 4. It just makes sense that when we're matching off, that the coefficient of the x up here, or the coefficient of the I down here, matches the coefficient of the I down here. Otherwise, this symbol obviously means something else. But we know what it means. It means this is the left-hand side is equal to or the same as the right-hand side. And that allows me to reason out, oh, the coefficient of the I must be the 2. So the b has to be equal to 2. The a has to be equal to 4. Now I can't remember the one in the... Oh, actually I have it here, I think. Now, I could be wrong, but I think you got to this stage, a plus b plus 2ai plus bi is equal to something like that. I could be wrong. Something like that. And it's like, right, well, have a look here. Like, look at the I here. So what's the coefficient of the I here? Oh, it's a 6. Well, what's the coefficient of the I over here? Oh, it's a 2a plus b. And that's where I got that line out of. It's not like I'm just dismissing the I. I'm just trying to match off what is equal to what. Or another way of looking at it is they're your imaginary. So 2ai plus bi is equal to 6i. You could just divide across by I because you don't need it. And that's where I got that. So whatever way you kind of want to look at it. And then here's your real numbers. And I know they're real because there's no I attached to them. It's not like I have a 5i or a 3i or 7i or minus 2i or a half I. No. So my real over here has to be equal to the ones over here that have no i's attached to them. So here's my real ones over here. And that's how I got a plus b is equal to minus 2 or whatever it was in the question.